The agent economy is active, heavily populated, and rapidly growing. Thousands of autonomous programs are attempting to interact, but the network itself remains inherently fragmented. These agents operate as standalone tools. They are intelligent within their own domains, but they lack the internal mechanisms required to reliably verify counterparty risk when interacting with an unknown entity. This creates a severe bottleneck for high-value agent-to-agent commerce. Because the programs cannot verify one another, compliance checks and risk assessments must be manually processed by human operators. This table illustrates the problem with the current siloed agent web. On the left side, counterparty risk relies entirely on guesswork and manual verification. Without a standardized protocol, developers rely on subjective trust, resulting in friction-heavy funds transfers that stall execution. The direct consequence is a strict limit on network volume. Cross-border agent-to-agent commerce cannot safely execute at scale if every transaction requires human intervention to clear compliance hurdles. The primary barrier to scaling the agent web is no longer artificial intelligence. The constraint is the total absence of programmable trust infrastructure. TrustGate provides the missing layer for this infrastructure. This diagram outlines TrustGate's architecture. It is a programmable compliance firewall, engineered entirely to protect the network. It automates the lifecycle of high-value transactions by replacing subjective risk assessment with deterministic mathematical proofs. Developers locate this infrastructure natively within the CROO Agent Store, where it exists as an available foundational API service. Integrating this specific firewall qualifies isolated high-risk agents as verified participants within a high-integrity economic network. We can trace this process by following the execution workflow, starting with the initial discovery and hire phase. The cycle begins when an external program, such as a trading agent, identifies a requirement for secure settlement and seeks out TrustGate to mediate the transaction. The developer integrates their agent into the CROO coordination protocol with a single command, npm install @CROO Connect SDK. From there, the trading agent initiates a direct service request to the firewall. It calls the TrustGate verify method, passing the counterparty transaction data directly into the system for evaluation. This single API call is the only manual developer intervention required. It triggers the entire complex compliance process automatically. Standardizing the integration into a single line of code lowers the technical threshold for building secure cross-border applications. In the milliseconds immediately following that API call, TrustGate begins internal processing. The system actively applies its proprietary risk classifier, running parallel evaluations on both counterparty credentials and regulatory exposure. This evaluation relies on specific cryptographic security primitives, BN254 and ZK-ElGamal. By utilizing these zero-knowledge primitives, TrustGate mathematically verifies the risk profile without ever exposing or reading the sensitive underlying data of the transacting counterparties. A successful cryptographic verification pass immediately generates an output hash. This highlighted text is a cryptographically signed ZK attestation. It contains the complete mathematically sound proof of the completed compliance check. This attestation acts as the specific cryptographic authorization required to trigger the protocol's on-chain escrow, providing the agent with proof. This mathematical proof is strictly necessary to satisfy compliance standards. Returning to our workflow model, this step is represented by the digital attestation, the definitive signal that allows the lifecycle to progress to the next stage. Because this attestation is strictly required to proceed, no transaction can advance without institutional-grade verification. Counterparty guesswork is entirely eliminated. The transaction now shifts from off-chain verification into the on-chain execution and settlement sequence. Looking at this architectural stack, the agent automatically presents the ZK attestation to the CCP escrow contract in the execution layer. The contract independently checks the proof's validity. Because it is mathematically valid, the contract executes, releasing funds to the settlement layer. The capital moves strictly as USDC on the base mainnet, leveraging account abstraction for frictionless transfer. In the final step of the lifecycle, TrustGate writes the complete interaction record to the distributed ledger. Bridging off-chain zero-knowledge logic directly to on-chain settlement enables autonomous, cross-border commerce equipped instantly with an immutable, regulatory-ready audit trail. Zooming out from a single transaction allows us to analyze the macro impact of this architecture on the broader network. This chart maps network scaling. The dotted line represents the friction of manual risk assessment. It creates a hard, flat ceiling on total possible growth. When ZK automated compliance replaces that manual friction, the network hits a severe inflection point, driving the curve sharply upward. By automating the verification process, the network safely clears thousands of secure connections in the time it previously took to clear one. This establishes a new metric, trust capacity. This is the maximum amount of safe network value an ecosystem can reliably support. By providing native, frictionless compliance, TrustGate creates the infrastructure to support significantly higher trust capacity across the network. The ultimate architectural outcome is an ecosystem where regulatory compliance facilitates, rather than restricts, the expansion of network volume. Operating this intensive cryptographic infrastructure requires practical commercial sustainability. The protocol natively funds itself by executing a per-call service fee ranging from 5 cents to $1. This micro fee covers the compute and ZK-proof generation overhead required for institutional-grade verification, ensuring continuous uptime without stalling transaction velocity. As shown in this final graphic, technical founders and developers can integrate this logic into their own applications immediately. Access the open-source CROO protocol via GitHub and deploy the TrustGate API from the CRO store today to begin scaling trust velocity.